morning. Today we are starting with a new topic, uh, symmetric matrix and skew symmetric matrix. I told earlier in the previous video, I told you what is transpose of a matrix, and now we are taking symmetric matrix. In symmetric matrix, first we should have a matrix A, which should be square matrix. So any square matrix I'm taking, first I'm taking a square matrix. This matrix is called as symmetric matrix if A is equal to A transpose. If the transpose of the matrix is equal to the matrix itself, then it will be called as a symmetric matrix. Or I can say Aij is equal to Aj for all I and j. Then this matrix will be called as symmetric matrix. Symmetric matrix means a matrix which should be a square one said to be symmetric if A is equal to A transpose, or I should say Aij is equal to Aj for all I and j element. That means if you have an example, if I take a matrix of 3 by 3, that is A11, A12, A13, A21, 22, 23. A31, A32, A33. If this matrix is a symmetric matrix, then one thing should be clear, these two elements should be same. 1, 2 should be same as 2, 1. 1, 3 has to be same as 3, 1. Then 2, 3 should be same as 3, 2. A11 not changing its position, A22 not changing its position, A33 not changing. So it can be anything, A11, A22 and A33. That means leading diagonal, any element can be possible. But here there is symmetry. A12, then A21 has to be equal. A13, A31 has to be equal. A23, A32 has to be equal. Now we'll take an example. A diagonal, I am taking any elements, 1, 2, 3. If this element is 5, then this has to be 5. If this is 6, then this should be 6 because it is 1, 3, this is 3, 1. If it is minus 2, then it is minus 2. Then this new matrix will be called as symmetric matrix. If you take the transpose of it, what you will find, just check. Transpose, I told you, the matrix, if you are taking any transpose of any matrix, then rows will change to column, column will change to rows. So first column will convert into row. Second column convert into second row. And third column will convert into third row. Are these same? Just check here. What I am finding here, A is coming equal to A transpose. Hence, this matrix will be called as symmetric matrix. So, symmetric matrix, first condition I told you, it should have square matrix. Second, A is equal to A transpose, or you can say Aij should be equal to Aj for all I and j. Then it will be called as a symmetric matrix. Now we are coming on second type of matrix, that is called skew symmetric matrix. Skew symmetric matrix. In skew symmetric matrix, there is a difference, slight difference, not much. First matrix should be a square matrix. I told you A is equal to Aij, order is n into n, square matrix must be there. And in this case, Aij must be equal to Aji minus. Aij must be minus Aji for all I and j. That means there is a difference of minus sign. In the symmetric matrix, I told they are equal, but in this case, numerically they are equal, but the sign has to be changed. That means this time A11, A122, A33. These are the diagonal elements. Here it will come A12, A13, A21, A23, A31, A32. this element and this element, there must be a difference of minus sign. Means if it is 2, then this should be minus 2. If it is 5, then this should be minus 5. If it is minus 2, then this should be plus 2. So these are the elements. A12 must be minus of A21, A13 must be equal to minus of A31, A32 must be minus of A32. So this means these are the elements should be negative. But what about the diagonal matrix this time? In the diagonal matrix, for diagonal matrix, for diagonal element, sorry, I comes out to be J, 1, 1, 2, 2, 3, 3. That means I is equal to J if we are taking, then what you will find in this relation, AII will be equal to minus of AII for all I. And from this term will go this side, so it shows 2AII is coming 0. What that indicate? AII is 0. That means this is for all I. That means in this case, whenever a skew symmetric matrix is there, the leading diagonal element has to be 0. Means this A11, A22, A33, these are the three elements which are going to be 0, because A11 and minus A11, these two can be equal only when both are 0. So that means the matrix, when you take skew symmetric, first thing their diagonal element has to be 0. If this element is 2, then this will be minus 2. If it is minus 5, then this will be plus 5. If it is minus 3, then it will be plus 3. This is your A. And if I take the A transpose of it, what changes? Just check here. First row will convert to column and column will convert to row. So this will be 0, 2 and minus 5. Then minus 2, 0 and minus 3. Then 5, 3 and 0. Just check here. What is the difference between this and this? Elements are becoming negative. That means A is coming out to be minus of A transpose. Then it will be called as a skew symmetric matrix. So one thing is clear. What is symmetric matrix? Symmetric matrix means A is equal to A transpose. Skew symmetric means the matrix in which A is equal to minus of A transpose. And here one more important result we got, that the leading diagonal elements has to be 0. Must be 0, all 0. Other elements are simply with minus sign. So this you should keep in mind. This is symmetric matrix and skew symmetric matrix. Now coming on some more properties. Properties of symmetric and skew symmetric matrix. First property says A if any square matrix. A is any square matrix. I am taking Aij, order is n into n. Then A plus A transpose matrix and its transpose if added is always symmetric. In a matrix, if you add its transpose, it will come out to be symmetric matrix. Just check here. Let P we are taking as the addition of two matrix A plus A transpose. We have to show that this is symmetric. Means P we should prove that it is P transpose. So what I take here, first I'll say P transpose is A plus A transpose whole transpose. Right or no? This implies P transpose will be A transpose plus A transpose whole transpose. This property already I told you. A plus B whole transpose is A transpose plus B transpose. So when you do this, what it will come? A transpose plus A transpose whole transpose is A, and you can write this as A plus A transpose because commutative valid property is valid. So A plus A transpose, and this is nothing but P. So what I get here, P transpose come out to be P. That means A plus A transpose is symmetric matrix. Next video, I'll take more properties here.